What drives our vehicles forward, bend and heats our rooms in cold winters? What keeps the huge factories running ceaselessly at high speeds? It all depends on energy, without which everything will stop. Energy is the cornerstone of our comfortable modern life. Today, we will take you to a new field to reveal how energy is driving the rapid development of China's economy and the challenges that must be overcome to keep the wheels of the country turning under pressure. The Gobi Desert in northwest. China engineers are searching for the enormous energy buried beneath the desert sand. Yan Heishang is a veteran blasting engineer with 37 years of experience. Today, he and his team will use 1,418 tons of explosives to blow to smithereens a 38-meter thick layer of rock in an area the size of 5 football fields. At the same time, they must make sure that what goes up comes down in all the right places. The first challenge Yan Heishang faced with is the charges cannot be set off simultaneously, which would result in destructive seismic waves.
We have 500 blast holes in a blasting area of this scale. If they are detonated simultaneously, the buildings nearby will likely collapse.
The solution is to detonate the explosives in batches. There are 781 blasting holes divided into 12 groups. Each group will be detonated less than 1/100th of a second after the previous crew. To make this work, the blasting team needs electronic detonators. With an encoder, the operator can accurately control the ignition of thousands of electronic detonators in milliseconds. The blasting interval is set to 8 milliseconds. The blast time is set for just after 4 p.m. It only takes a second to know the result. It happens in the arid inland beside the desert. The Chinese have invested billions of dollars to build facilities to produce this. The coal found here is of superior quality. While having a very high heat value, it contains less sulfur and is therefore less damaging to the environment. Today, coal is still the main energy that drives more than half of China's economy. This is one of the open-cast mines operating in China. The coal is of quality and the seams are very thick. Coal seams of over 15 meters in thickness are regarded as super high seams across the world. And the seams here are up to 30 meters thick. Of course, in order to mine this precious coal, the upper layer of rock needs to be removed. Before receiving the formal command of detonation, the blasting team has carried out the final checks on their electronic detonators through an encoder. By 4 p.m., the billions of dollars worth of equipment in the mining area have already been moved to safety.
The control area is on alert. They are all in safe place. We are ready.
Good. Okay, let her rip. Power on.
8, 7, 6, 5, 4, 3, 2, 1. Detonate!
As usual, Yuan goes on his own to the blasting area to check on the results.
The result is good. The fracture looked nice.
It seems Yuan is quite satisfied with the result of today's blasting. After removing the gravel, a new coal seam reveals itself. Half an hour later, the smoke is cleared, then the mining operations resume. The daily output of coal from this man-made canyon is over 100,000 tons. It could generate enough power to supply one modern family for 10,000 years. But it's just 1% of the daily output of China. Coal occupies the primary position in China's energy structure. Because of that, it is particularly important to use coal efficiently. One of the most efficient ways is to build large power plants near to the coal fields. This reduces transportation costs and keeps pollution to the remote areas far from the cities. The west of China has a substantial coal reserves, but it is very short of water. And that is a big issue when it comes to cooling these power plants. Zheng Wenlong, head of maintenance, is going to carry out a special project today. To build a thermal power plant in a desert was impossible in the past. Because a traditional thermal power plant needs so much water for cooling, the boiler cannot operate without it. The higher the power, the more water consumption. But what the Gobi Desert lacks most is water. However, China has begun to build large thermal power plants in the desert because it has found a solution. The secret lies in these passive cooling towers which do not use water. As the hot air rises from the top of the tower, cooler air is drawn in at its base over an array of radiators. Zheng Wenlong's job is to keep the radiators clean. He has to clean nearly 1 million square meters of radiators with the least amount of water he can. To achieve a better cooling effect, the 132 radiators are distributed in a V-shape with an area of 970,000 square meters. As this type of passive cooling tower does not directly need large quantities of water, it is possible to build them in the desert. The east of China is home to just under 70% of the country's population and over 80% of its economy. However, most of the new energy resources are in the west, thousands of kilometers away. The energy transportation has been a problem for the country for quite a long time. China plans to build more large power plants around the coalfields of western China, convert coal into electricity, and then let the power grid carry it to the east. It is the largest energy transmission project in human history. Today, the project begins a new phase. The installation of the conductors. At the foot of pylon number 323, the linesman is getting ready to join the conductors high up in the air. This is the world's longest and highest voltage power transmission line. It starts in the Yunga Basin in the far west of China and runs for 3,324 kilometers across deserts, mountains, canyons to the densely populated east. In 8 years, China has built more than 30,000 kilometers of high voltage lines to establish the world's largest energy transmission network. To increase the system's efficiency, the voltage needs to be raised. The 1.1 megavolt high voltage line is the highest in the world. At present, it can transmit the energy generated by 80,000 tons of coal over a distance of 3,000 kilometers in a day. To ensure the transmission runs smoothly and efficiently, the 20,000 conductor joints have to be connected perfectly. The cables are connected by intense pressure. First, the outer aluminum wires are stripped back to expose the steel core. Then the two ends of steel core are inserted into a metal sleeve. A hydraulic clamp presses hard on the sieve to hold the two sections of steel cable firmly together. After the steel core is joined, a larger sleeve is used to connect the outer aluminum wires. The procedure seems simple enough, but it's quite another thing to do it 100 meters up in the air. With everything swaying in the breeze, the workers need to hold two ends of the cables carefully and avoid damaging the conductors while dealing with the 5-ton tensile drag on the cable. To manage this, they must use a special cable clamp.
First, unlock it, put the wires in. It gets tighter and tighter. After you put in the wires, lock it. The wind is rather strong here. Normally, the tension on the line is up to around 5 tons. The wind adds another 2 to 3 tons, sometimes even 4 tons. The tensile force can increase to over 10 tons. Pull the rope a bit tighter. Slower. Keep on.
The procedure is the same. The only difference is they are now doing it at the height of 100 meters. The job not only requires concentration, but also a head for heights. It will take 6 months to complete the new 33-24-kilometer line. And this is just the beginning. In this country, several more are being planned to follow. Early November, a deep-sea engineering vessel is anchored off the coast of South China. The sea is calm, but Captain Jin Ruijian is not. He needs a storm, and he has already been waiting for 3 days. The new ship has been built at a cost of $200 million due to its performance in deep sea. The waters around China are greatly affected by the Western Pacific Ocean currents. These prevent divers from conducting deep-sea seabed operations. This ship has been built to deal with that challenge. Thus, to test the new ship's ability to work in rough sea conditions, Captain Jin's crew must wait for some strong waves. Historically, it has been very difficult for China to develop deep-sea oil and natural gas resources. Hopefully, this will change if this new ship tests successfully. It depends on whether the advanced equipment on board function as intended. The expected wind and waves do not arrive. Captain Jin has to look for another storm.
Captain Jin, this is the weather chart for the next few days.
Thank you. According to the weather chart, there will be force 4 to force 5 winds today and tomorrow. The waves will be 1.5 to 2 meters high. That's not good enough. We need waves at least 2.5 meters high.
The latest weather forecasts leads the captain and the navigator to choose a new test area. After a night's sailing, the ship reaches its destination. As the sea gets up, the test commences. The key requirement for accurate underwater operations is that the equipment is stably maneuvered. In order to achieve this, the engineering ship has to remain in a fixed geographical position against the flowing currents and heavy seas. This is done by the approach power compensator system. That is to say, when waves drive the ship off position, the compensator system instantly starts the corresponding thruster to offset the force of the sea. This keeps the ship in a steady position. However, this equipment alone cannot fix all problems. When the ship rolls or is lifted by the waves, the thrusters alone are not sufficient. But this new ship has another piece of special equipment. The world's largest crane with an automatic height compensation system. The high-power crane is able to lift up to 400 tons as the ship rises and falls in the swell. The crane automatically detects the speed and direction of the movement. It then reacts instantly to compensate for this by retracting or paying out its cable lines or by turning its lifting arms.
The waves are a bit small, so we'll wait for a while.
Now let's adjust our course to pick up more swell.
I'll talk to them.
To make full use of this right sea conditions, the tasks must continue well into the night. Images from the underwater camera show the 400-ton test box only moves slightly, despite the surging waves. It is well within the control range. Everyone is very pleased with the result.
We have asked for their opinions. The compensation effects are completely acceptable.
Okay, we've done it. Thanks, everyone.
With the advance of deep-sea engineering technology, mankind has made a further step in acquiring resources from the oceans. The energy stored in the deep sea is beyond imagination. On July 9, 2017, a research team departs by helicopter for an offshore platform. Today, they will witness a historical moment. 2 hours later, the team have arrived at their destination. Blue Whale 1, the largest deep-sea operation platform in the world. It has been in the sea for several months already. The flames show that it is working busily below the surface. The burn-off may look fairly normal, but its energy comes from special material. In fact, what the team are doing represents a world-first energy extraction test. Long ago, humankind has discovered the methane hydrate, also called combustible ice. It forms the largest reserve of fossil. In the future, people who have the ability to extract will change the world's structure of energy. However, the methane hydrate has been found to exist mostly in deep sea, mixed with mud and sand. By far, extracting is no simple matter. Reliable mining techniques have yet to be developed. A previous mining test only lasted for 12 days before it failed. This time, the Chinese research team has made a key breakthrough in continuous and controllable mining of fire ice. So far, the team have been mining for 60 days, a new world record. With extensive data gathered in 60 days, the team decides to stop the test.
Director Ye, the closing down procedure is ready.
I hereby announce the shutting down of the NGH test mining program in the South China Sea.
Command Center, the choke valves have been closed off.
At 8:03 p.m., the engineers switch off the valves. The test will move to the next stage. Results show that methane hydrate reserves is the most among all fossil fuels. Their breakthrough and mining technology can have a profound impact on the future of energy production. The rapid development of China's economy demands more energy. The use of traditional fossil fuels will cause enormous environmental damage. China is making conscious efforts to increase the proportion of clean energy in its energy mix. Today, the work has yielded preliminary results. The Chinese once again lead the world in the field of water power. This is the construction site of the Wudongde hydropower station. It is the first cascaded hydropower stations in the upper reaches of the Yangtze River. The excavation works have been completed to build a huge facility on the mountainside to take the giant hydraulic turbines. The workers now are casting concrete to build the dam at the end of June. The usually hot, dry weather turns to continuous rainfall. This is bad news for chief casting engineer Yang Ning.
We are going to pour concrete in the catchment area of 2 steep dam blocks. If it rains, the water accumulates there along the side slope. If the blocks are inundated, we won't be able to control the build quality.
The engineer are planning to cast a seamless concrete dam. Across the world, concrete fracture is a recognized technical bottleneck. The larger the project, the more serious the problem. There's an engineer saying that every dam has fractures. It will take 2.91 million cubic meters of concrete to cast the Wudongde Dam. The plan calls for a wall 275 meters high and between 12 and 51 meters thick. Here to withstand the pressure from up to 270 meters depth of water, the dam cannot have even the slightest fracture. The key to building a seamless dam lies in the continuous control system. The casting process has to go on continuously for 33 months without interruption. Yang must find a way to avoid the operation being blighted by rain as soon as possible. Yang Ning faces a dilemma. If they cast in the rain could alter the composition of concrete. If the casting stops, the concrete components cast before and after the rain will not marry properly. To work through the rain or wait for it to clear up, a decision has to be made. The rain is forecast to have cleared the area by the 29th. Yang Ning decides to start the operation as soon as possible. It stops by 8 in the morning. The wet weather has passed. 30 minutes later, the temperature-controlled concrete arrives on site.
It is strictly forbidden to pour concrete in the rain. We have to complete casting this block by 2 or 3 p.m. before the rain restarts. This is to guarantee a firm connection between the fresh concrete and its foundations.
The heat generated as the concrete sets is the main cause of cracking. As the concrete has almost no malleability, and the internal and external cooling speeds are different. This uneven thermal distribution is what can lead to cracks. To build a seamless dam, the key is to achieve precise temperature control during the continuous casting process.
When you do it, fix this place. Don't let it move.
Yang has made a timely decision and has successfully avoided the bad weather. When the plant is completed, the mighty river waters will be harnessed to the grid. However, rich water resources are not found everywhere. The town of Delhi in the west of China is short of water, but has plenty of sunshine. The power of the sunlight and the number of hours the sun shines makes it an ideal site for solar arrays. Before sunrise, the maintenance engineers have to get to work early in the day.
Initiate a preemptive tracking command for 130 and 131, and I'll check if they can activate.
The key components of the array are these mirrors. When sun rises over the Gobi Desert at 7 in the morning, more than 20,000 mirrors bounce the light with great precision to the top of a tower. The heat generated there is absorbed by molten salt, which takes the heat down into the plant, where water is heated into steam. Which drives the turbines to generate electricity. This way of generating electricity does not consume any fuel or discharge any emissions. It is an ideal way of utilizing solar energy. There is one catch, though. The sun keeps changing its position. If the alignment of the mirrors is slightly off, there will not be enough energy to heat the salt atop the tower. To solve this problem, China has developed a precise sunlight tracking system for this tower type of photothermal power plant. Controlled by a computer, the 20,000 mirrors reflect the sunlight to the top of the tower when unerring accuracy. This is tower type of photothermal power plant. The conditions of the region lend themselves to solar power, general, but there's more than one way to turn rays into volts. Not far away, another solar power plant 10 times of its size is under construction. It is a Tromp-type photothermal power plant. Unlike the tower-type power plant, it collects the heat of sunlight through curved mirrors. However, both systems rely on precise solar tracking. Therefore, Quality Control Manager Gu Wenshui monitors the installation of every trough concentrator. A trough concentrator is made up of perfectly curved mirrors. They track the sun under the control of computer. If a parabolic solar trough is not smooth, the reflected light will not be accurately focused. The installation must again be done to very precise tolerances.
We integrate every European trough into a hole. This is to guarantee synchronous rotation and reduce the horizontal and vertical errors to less than 1 millimeter.
The area of each parabolic trough is 69 square meters. After installation is completed, the mirrors will be aligned to within less than 1 millimeter. This plant will have 9,120 solar troughs. Every unit's installation must meet the standard. After 8 months, more than 9,000 reflecting units will rotate with the sun and gather its heat to generate 50,000 kilowatts per hour. Today, China's currently installed solar power capacity exceeds 70 million kilowatts, accounting for 1/5 of the world's. More and more ways to utilize solar energy will revolutionize China's supply of clean energy. Its rapid development shows China's genuine determination to change its energy structure. But there are other emission-free energy sources to be tapped into: wind. In China, giant turbines are a common feature of the landscape in many locations. Wind energy is often harvested more reliably at sea, but the harsh environment has posed serious challenges to the installation and maintenance of the turbines. Previously, when turbine generators were assembled on land and then ferried to their operating sites by semi-submersible vessels for final erection, the process was costly, slow, and resource-intensive. Today, offshore wind is looking more and more like the future of wind power. Breakthroughs and installation technology will greatly reduce the cost. On the eastern coast of China, one of these new installation methods is still being trialed. What is new is that they are adopting a new installation method, which is still in full evaluation. To ensure tomorrow's trial runs smoothly, Operations Director Liu Pengyuan is working late, checking all the equipment.
Is this position limiter mechanical or digital?
It's mechanical.
Where is it? Not this. When you find it, replace the part, and then we'll know for sure.
The new method depends on this newly developed tool. They can accurately set the angle of a blade at a height of nearly 100 meters, so that it is perfectly aligned to the rotor hub. If the machine works, as it should, the cost of installing offshore wind turbines will halve. By 11 at night, the engineers have finished tweaking their setup. The following day, the crucial test will begin at 7 in the morning.
Turn left a little more.
Two hours later, a 50-meter long and 20 tons blade is lifted to the hub. Now comes the tricky part. The crew needs to marry the blade's fastening bolts where the slightest to the rotor hub. 100 meters up in the air where the slightest breeze can push everything out of alignment. This is when the new clamping system comes into its own. It allows the operator precise control over the blade's position and connect it to the hub with pinpoint accuracy. Three hours later, the rotor blade is successfully installed. This new method of installation will dramatically reduce installation costs and put you live in the sales of the offshore power generation industry. In China, the progress of science and technology drives energy development, and a mixed-source energy policy is the outcome. On a remote peninsula in eastern China, the most advanced nuclear power unit in the world is being prepared to be put into operation. The nuclear reaction releases enormous heat. This is used to turn water into high-pressure steam, which drives the generators to generate electricity. The core of a nuclear power plant is the reactor unit. This nuclear power unit is built to the world's highest safety standards. Before it starts operations, many and repeated safety inspections have to be completed. The engineers test a 3-story high safety door. It is made of special metals and manufactured with aerospace technologies like the safety door nearly. In the plant, 1/3 of the components are built with the ultimate goal of safety. This 10-meter deep pool on the reaction chamber next to it are at the business end of things.
Now we can get close to it. We won't be able to do this in the future because it will be highly radioactive.
In due course, the pool will be filled with pure desalinated water. The installation and replacement of the fuel rods will take place here.
Ahead of us is the most crucial part, the nuclear pile.
Mr. Nan, are you coming down?
Yes, we are. When the generator runs in the future, all the energy will come from here.
The last round of inspections will soon be completed. The nuclear fuel has long been ready in the fuel deck. Before loading, they are stored at the highest level of security. More than 100 fuel units sufficient to drive the plant are already in the fuel bin. Below this floor lies stockpile of the most powerful energy source mankind has yet been able to harness properly. Its energy density is 2.5 million times that of coal.
We are going to load the fuel. Today we will do a simulated drill. First we must check the conditions of the equipment, adjust our equipment to the best condition.
The mechanical arm grasps the nuclear fuel assembly. Each is composed of 264 metal tubes filled with nuclear fuel. Before the startup, they are not radioactive. Repeated rehearsals are to ensure that the installation is foolproof. The operation is repeatedly rehearsed for 4 hours a day. Until today, people have been exploring the best way to make use of nuclear energy. Sun, the source of all energy. The way it produces energy is called nuclear fusion. Within the scope of humans' knowledge, nuclear fusion is the most ideal way to make use of nuclear energy. On July 5, 2017, Chinese scientists released 100 seconds of video which amazed the world's scientific community. The video shows an experiment in which Chinese researchers managed to achieve a temperature of 50 million degrees, sufficient to overcome the barriers to fusion reaction. But no known material on the Earth can handle even 1/10,000th of such a temperature. What kind of vessel could contain such a high temperature reaction? The answer is a magnetic field. The coil enters a superconducting state at low temperatures, producing the strongest magnetic field on the Earth. In this can float the materials for a fusion reaction suspended in the air.
This is the superconducting magnet we are building. The superconducting coil will be put here and cooled to 269 degrees below zero. It will experience the highest temperature in nature. Plasma of hundreds of millions of degrees will be in this very narrow space. The construction of this device is very difficult. Our research in plasma physics is world-leading. We have a lot of core technologies in the field of nuclear fusion. I think this can be a source of national pride.
Nuclear power is the best solution to the energy problem known to mankind. On this road, Chinese scientists have found the right direction. While looking for inexhaustible energy for the future, we should pay more attention to figure out how to use today's accessible energy in a cleaner, more sustainable, and more environment-friendly way. This is not an easy task to fulfill, which requires more innovation and, of course, more efforts.